section 7.8 is on inverse functions. So inverse functions, we talked about the word inverse a lot of times in Algebra 2 so far. Do you guys remember when we talked about inverse matrices? So inverse matrices, we wrote like A inverse like that. We're going to use that symbol, that -1 exponent, as our symbol for inverse functions as well. So we've also talked about additive inverse and multiplicative inverse, so way back when. So the additive inverse of 3 was -3, and the multiplicative inverse of 4 was 1/4. So like the additive inverse is what you add to get 0 out, and the multiplicative inverse is what you multiply to get 1, right? Do you guys kind of remember this in the way back in your head? All right, so the inverse relation for all the ordered pairs x, y is the set of all ordered pairs y, x. So all we're going to do is we're going to switch the x and y values. So it says graph the relation and connect the points with straight lines. Then we're going to graph its inverse, and we're going to identify the domain and range for each relation. So we don't typically like connect them with straight lines, but we'll go ahead and do this for this example. So the first one has the point 0, 2, because 0 for x, 2 for y. The next one is 1, 5. And then we have 5, 6, and we have 8, 9. Like that. Okay, so if I connected those with straight lines just to kind of see what the shape is, it looks like that. Like I said, we don't typically do that. We're just going to do it here so we can see a reflection on this other one. All right, so now if I talk about the inverse. The inverse is going to take all of those x values that we had before, and it's going to switch them and make them y values. And all the y values we had before are going to switch and become x's. So instead of having 0, 2, I'm going to have 2, 0. Instead of having 1, 5, I'm going to have 5, 1, and then 6, 5, and 9, 8. So when I graph this one, I'm going to have 2, 0, 5, 1, 6, 5, and then 9, 8. And if you notice, when you connect all of these with straight lines, do you guys see how it's kind of a reflection? Like I can fold it over on itself. And the line that it's going across is the line y equals x. So that's the line that it's reflected across. Okay. So if I was going to talk about the domain of the original, our domain would be all the x values. Now, since I said I don't typically connect those with straight lines, it would just be only 0, 1, 5, and 8. That would be our domain. And our range for the original would be 2, 5, 6, and 9. So what do you notice about the domain and range for this one? They're switched, right? Because we switched all the x's and y's, and domain was all the x's and range was all the y's. So now when we switch them, now our range is our domain is going to be the old range. So 2, 5, 6, and 9. And then our range is going to be the 0, 1, 5, and 8. Okay, so domain and range switches. So inverse functions are functions that undo each other. So often when you see like multiply by 3, its inverse is going to involve divide by 3. If you see like adding 2, the inverse is going to involve subtracting 2, and so on. So in this first example, it says that we have the function f of x equals x plus 6. So if we put in 3, we get 9. If we put in 4, we get 10. If I put in 5, I get 5. So I want to know, what is the function, and I'm going to write it like f inverse, f to the -1, kind of like our matrix inverse, remember? What's a function that if I put 9 in, I get 3 out? If I put 10 in, I get 4 out. If I put 5 in, I get 5 out. What do you guys think? Caleb? It's easy. It involves a -6, right? So x minus 6. Do you guys see it? If I put in 9, do I get 3? If I put in 10, do I get 4? If I put in 5, do I get 5? Yeah, it totally works. So that's what our inverse function is. But it's not always that simple. So you can't just guess. Like I can't look at number 1 and be like, I'm probably going to have a divide or a times 2 and a minus 5. So I don't know, I'm just going to say 2x minus 5. It doesn't always work that way. Okay, so we're going to have to think about it. Yeah.
I guess I'm a little confused because when you put 5 in, it gets...
Oh, sorry, not 5. What am I talking about? When I put 5 in, I get 11. I don't know what I was doing there. Yes, that's a bonus point for Greta. So if I put 11 in, I get 5. So, so let's find the inverse of each function. So we're going to follow the steps. So the steps are in the box. So step 1, f of x is really just y, right? So I'm going to rewrite it. So I'm like, okay, it's y equals x plus 5 over 2. And then step 2, switch your x and y's. Just like we did with the points, we're going to switch the x and y values, right? So I'm going to write x equals y plus 5 over 2, like that. Now I'm going to solve for y, so solve for the new y. So I'm going to multiply the 2 over, and I'm going to subtract the 5. That's what y, I know. That was a lucky guess, wasn't it? It's not always going to be that easy. All right, so we end up getting f inverse of x is equal to 2x minus 5. Okay, so it often has something to do with what you thought it was going to have. Like we said, dividing by 2, we're probably going to have a times 2. Where we had a plus 5, so we're probably going to have a minus 5. But oftentimes, like parentheses and so on, will mess your prediction up. Okay, so don't just guess your way through these. You really should do the process. So this next one, so I have f of x, that's y, right? So you can write it as y if you want to. Or you can kind of combine these two steps and you can say x equals the cube root of 2 plus 5y. So you can kind of eliminate that first step and just go straight to that if you want. All right, so how am I going to get rid of the cube root? Cube both sides. So I get x cubed equals 2 plus 5y. So I raised each side to the 3. Subtract the 2 over. And divide by 5. So that's our y equals x cubed minus 2 over 5. So instead of writing y equals, I'm going to write it as f inverse of x. Like that. Yes?
Did you just like switch like in the first and second step, like the x and y?
That's part of the steps. So see where it says switch your x and y values? That's part of our steps in order to find the inverse. I know, it seems weird, doesn't it? It's like, how can we just do that? But that's what we did with all of our points, right? We did 2, 5, became 5, 2, right? So that's what we're doing here. All right, I do want to mention some people get confused when they see f inverse of x. They're like, oh, f to the negative 1, that's just going to be 1 over f of x, right? Those are not the same thing. Don't do that. So just because I know it says like f to the negative 1, sorry, that ran together, that doesn't mean 1 over f of x. That worked for x to the negative 1. Do you guys remember that? We run out of symbols in math, and we make things confusing for you. I understand. That's what we do as an inverse. The same thing happens with inverse sine, inverse cosine, and so on. You guys used inverse sine and cosine in geometry. You probably don't remember, but you guys remember doing like inverse sine of something. That was not 1 over sine, so it doesn't mean the same thing. We just use that negative 1 as an inverse. All right, so this one, so same idea. So let's go ahead and try to find the inverse. So switch your x and y, solve for the new y, see if you guys can do it along with me. So I have x equals negative 1/3 y plus 4. I'm going to subtract that 4 over. No. And I need to get rid of that negative 1/3. So I'm going to multiply both sides by negative 3. So I end up getting y equals negative 3 times x minus 4. Or you could have negative 3x plus 12, right? Caleb tried to guess up here. He got it wrong totally. See, that's why I tell you not to guess. I have a lot of people do this on the test every year where they're just like, I'm just going to guess at the inverses. I'm like, this isn't a good plan. Like, just do the 3 steps that lead to the right answer. All right, does this make sense? You guys get it? All right, you know it's going to get harder, right? Of course. All right, this one's not that bad. So a couple different things here. Like, you could have y equals 5x minus 10 if you want to distribute first, and then you can switch your x and y. It doesn't actually matter. So let's say we do that, and now we switch our x and y. And then we solve for y, so I'm going to add the 10 over, and then I'm going to divide by 5. So I get y is equal to x plus 10 all over 5. All right, that's your f inverse. But your answer might look slightly different than your friend's answer. So if you guys check your homework on Tuesday or whenever, Wednesday, I guess when I see you, you might see that your friend has 1/5 x plus 2. That's exactly the same thing. Do you guys see why it's the same? Like if you bring this 5 into here and here, x over 5 is 1/5 x. 10 over 5 is 2. It's the same thing. But the reason that your friend might get 1/5 x plus 2 is because maybe they started with the original and they switched their x and y and they didn't distribute that 5 in. And they just went ahead and divided by 5 before they began. So they had x over 5 equals y minus 2, and then they added the 2 over. Does that make sense? So just know that you could have something slightly different. At least you with me. All right, so this next one, so this is where it starts to get weird. Are we ready for the weird ones? All right, so let's say we switch our x's and y's. So I get x equals 2y minus 1 over 3y plus 4. This one is different than what we've done so far. So what is making this one not so nice? Yeah, do you guys see that there's 2 y values? So it's like, wait, we're supposed to be getting the y by itself. But now we're like, crap, there's 2 y's. So in order to do this, we're first going to get everything on one line, meaning we're going to take that denominator and we're going to multiply it to the other side. Yeah, you're just multiplying your denominator over, just like if you had, like, we can write 3x equals y, right? Something like that. We're just taking that and multiplying it to the other side. All right, and then we're going to distribute. So we're going to get 3xy plus 4x equals 2y minus 1. And we still have 2 y's. So now here there's going to be a key. And so when you get stuck, you're going to be like, okay, every time this happens, I'm going to do exactly the same process. So what we're going to do is we're going to get anything that has a y on one side of the equation, anything that doesn't have a y goes on the other side of the equation. So all of the y's go on one side. All y's on one side. Everything else on other side. All right, so this had a y and this had a y, so we're going to get all of those on one side. So I'm going to subtract the 2y over here. So I have 3xy minus 2y. And then I'm going to subtract my 4x over there. So I'm going to get minus 1 minus 4x. Okay. And we do this for a reason. Okay, so now we have all of our y's on one side. So what do you think we're going to do? Kind of almost there. Yeah, first we're going to divide the y out. We're going to factor the y to the front. So the y is going to go to the front of the parentheses, and then I have 3x minus 2. Now do you see how we get the y by itself? So now we have y equals negative 1 minus 4x over 3x minus 2. That's our g inverse. So we write it as g inverse of x. It doesn't matter if it was g or f of x or what it was. Yeah?
Do we have to put g as an inverse?
I always do.
Will we be counted off if we don't?
I probably won't count you off, but you should always try to please your math teacher when I'm grading your papers, right? Yes, Greta?
So I did it the other way around.
Ah, good question. So Greta says, you know, I feel like I did the right steps, but instead of subtracting my 2y to the left side and subtracting my 4x to the right side, she did it the opposite, right? So she took the 3xy and subtracted it over. And she took the 2y and subtracted that to the left side. And so I'm guessing that Greta got 1 plus 4x over 2 minus 3x, or 4x plus 1 over 2 minus 3x, which is totally fine. So think about it. How is Greta's answer different than our answer? Yeah,
It's multiplied by a negative.
exactly. So if you're checking your homework with a friend and you're like, oh crap, we didn't get the same thing. See if you can multiply by negative 1 on the top and bottom, like Matt's saying, and see if you get the same thing. Does that make sense? Those are exactly the same. So it just depended on which side you got your y's on which answer you have. Now, if this was on a standardized test like the SAT or something, what they would do is probably write it with the least number of negatives. So sometimes even when I get that answer of negative 1 minus 4x over 3x minus 2, I'm like, oh, there's too many negatives, and then I multiply through by negative 1 on top of that. So it's up to you guys. All right, so this next one is going to be the same process, but we have a 5x under. So when I switch, I'm going to have x equals 2 plus the square root of 5y, and I have 2 minus the square root of 5y, so I switched my x and y. And now I'm going to solve for my y. So I'm going to do the same thing. I'm going to multiply the denominator over. So I'm going to take this and I'm going to multiply it to the other side. So I'm going to have x times 2 minus the square root of 5y is equal to 2 plus the square root of 5y. Oops. Get a little close there. And I'm going to distribute. So I'm going to have 2x minus x times the square root of 5y equals 2 plus the square root of 5y, like that. Then I'm going to get anything that has a y on one side. So it doesn't matter which side you get it on. So let's say since it has minus x squared of 5y, I'm going to add that to the right-hand side. And I'm going to subtract the 2 to the left-hand side. So I'm going to have 2x minus 2 equals x square root of 5y plus the square root of 5y. So it's the same process as the last one. It's just a little bit harder because we have a square root of 5y, not just y. Now what do you think? Yeah, pull out the square root of 5y. So when I pull out the square root of 5y, I'm left with not just x. A lot of people just write x. X plus 1, right? Equals 2x minus 2. And then we divide. So we're like, okay, now I'm going to divide by x plus 1, divide by x plus 1. So I get 2x minus 2 over x plus 1 equals the square root of 5y. So that's kind of like where we were before, where we solved for the y. We got the y part by itself, and we were done there. But we're not quite done now because we have that square root of 5y.
Square it.
Yeah, square it, right? And then divide by 5. So we're going to square both sides. So we're going to have 2x minus 1 squared all over x plus 1 squared. You don't have to FOIL it out, no worries. Equals 5y. Okay? And then I divide by 5, but I don't want this to be what we call a complex fraction. It's literally called a complex fraction, because it's complicated. I don't want this whole fraction divided by 5, because that looks messy to have a fraction within a fraction. So think about that. If I had 2/3 equals 6y, we don't want to write our answer as 2/3 divided by 6, right? That's weird. So what do we do instead?
6.
Yeah, multiply by 1 over 6, right? So in our example, what are we going to multiply by? 1 over 5. So that will end up putting it on the bottom for us. So our final answer will be y, which is, was it g originally, or 8, or f of x? F of x. So I'm going to write f inverse of x equals 2x minus 2 squared all over 5 times x plus 1 squared. And you could FOIL it all out if you wanted to, or you can leave it like that. I'm fine with that. Some people might even pull out the GCF of 2 and then square the 2. I mean, there's crazy things you can do there, but that's good. All right, does this make sense? All right, so let's also, well, maybe we'll stop there for today because we only have 5 minutes left. So remind me to record the rest of this video tomorrow, but I'll add that at the end. All right, I'm going to stop there.